Sheridan began constructing its third-generation district energy system in the summer of 2016, burying 3.5 kilometers of pre-insulated pipes that carry pressurized hot water across the campus from a central plant to every building. Reciprocating heat and power engines installed in 2017 and 2018 generate baseload heating for the system, along with a modest amount of electricity. Supplemental boilers provide additional temperature lift on very cold days. Well, at its most basic, the district heating system takes heat from a central location, distributes it through a bunch of pipes like the ones here, and then it's picked up by different buildings across the campus. When Sheridan looked to select a manufacturer for its energy transfer stations, we were looking for firms that had a global reputation, had been manufacturing them for decades, and it was critically important for us to find a partner that would help us build the supply chain here in North America. And that's really where Danfoss stepped up. There were 3 main challenges during the installation of the energy transfer stations. One was that we're working in existing buildings, so there were extremely tight physical spaces where we were going to bring the equipment into the buildings, as well as where we wanted to install them. The second, we were working in buildings that were occupied, running classes, and we really couldn't have the work of interfacing buildings to the network be really disruptive to the operations we had. The third point is that we knew we'd be running our schedule right up into the heating system, and that we really wouldn't have a lot of time to cut over the system from old system to new. Danfoss worked early on with our engineering team, not only to ensure that the units were sized right from a heat capacity perspective, but also to really address the physical space constraints we'd have. And then finally, once the devices were on site and we were installed and ready to go, the engineer came out and ensured that everything got commissioned properly and that we were up and running very quickly. Prior to the switch to district energy, the college's steam plant was losing about 65% of the heat it generated. Following the conversion to the hot water system, natural gas consumption was reduced by 20%, which equates to an annual carbon reduction of 530 metric tons. Sheridan's district heating system creates an energy network where heat can not only be recovered and reused within campus buildings, but can be recovered and supplied to buildings in the larger community. The college hopes to eventually connect the college's energy system to a larger municipal district energy network.
How Sheridan plans to expand the district energy system is that when we actually built the system, it was built with connectivity in mind. So our goal is in the long term for members of the community, like the municipalities or our surrounding neighbors, to connect into the network so we can work with them to share the energy savings and reduce the overall carbon footprint of the community. This really reflects the college's mission, because one of the key components of our mission is ensuring fiscal and environmental sustainability. To that end, in 2021, Sheridan signed the SDG Accord as the first Ontario institution to do so. And the SDG Accord is the post-secondary sector's response to the United Nations Sustainable Development Goals. Our district energy centers are a key part of us achieving these objectives, with the goal ultimately of doing our part to build a better future for everyone.